Last session we discussed about microprocessors and how exactly the microprocessor works, and even we have discussed the different types, or we can say the classifications of the microprocessor. In that we have discussed about the RISC processor and CISC. RISC, in that RISC is a reduced, what exactly the RISC? It's a reduced instruction computer set, and in that we have seen the different features of the RISC computers and even the different characteristics of the RISC. And then we also discussed about CISC. It's a complex instruction set, basically to increase the number of instructions. Obviously in the RISC it was only one cycle, here more number of cycles, because there was no focus on that, because the intention is to reduce the number of lines of code. Obviously the compiler job will be like the very little work for the compiler when you compare to the RISC. And also we have discussed some of the characteristics with respect to the CISC. These are the topics which we have discussed in the last session. Right. Today in this session we will talk about the memory units. Memory are nothing but the storage. For anything, if you want to perform something, obviously the storage unit is a must. Right. We will try to understand the units of this memory are nothing but the storage. The memory unit is the amount of data, how much data that can be stored in one unit or storage unit. If you have one computer or if you have any device, obviously we need to talk about the storage. What is the storage capacity? Right, how much data you can store that. So the same concept we will try to understand. Basically memory unit is the amount of data that you can store in the storage unit. So the storage capacity always expressed in terms of bytes. That is very important. Right. Always we will that we can say the unit, measuring unit. The storage capacity we will be expressed in terms of bytes. And maybe what exactly byte or bit we will try to understand through this table. So bit. So anything which we send, that instructions will be in the form of binary digits, that is zeros or 1. So that is called bit. It's a binary digit, nothing but 0 and 1. That will be representing a passive or an active. It is nothing but most of the, if you talk about programming language, if it is true we call it as 1, if it is a false it is a 0. Similarly, anything which you want to process, everything will be consists of these binary digits 0 and 1, that will be representing a passive or nothing but a active state of the component. When we are talking about an electric circuit, because so that is whenever we are talking about bits, zeros and ones, that is with respect to the programming instructions, but now we are talking about the circuits, because a microprocessor, or because how exactly the data will be stored. So electric circuit, how exactly this bit will be, or nothing but the binary digit will be representing your passive and active state in an electric circuit. And now next another important unit, storage unit is, we call it as nibble. That nibble is nothing but it's a group of 4 bits. One bit is nothing but 0 and 1. Here such 4 bits we call it as a nibble. And next byte. So I think in the previous slide we discussed, right, always the storage capacity will be expressed in terms of bytes. So now we understood what is bit. Bit is nothing but 0 and 1, it's a binary digit. We also call it as a binary digit, and all your electric circuit, your passive and active state will be representing through this binary digit, and a group of such 4 bits we call it as a nibble. Similarly, now we talk about byte. So because storage unit will be expressed or measured in terms of byte, group of 8 bits. One bit is nothing but binary digit 0 and 1. Such bits are required, or 8, that will form 1 byte. So a group of 8 bits is called a byte. Byte is actually, it's a very smallest unit that can represent a data item or a character. If you want to represent, or nothing but a byte is the smallest unit, that representation, that byte will represent, or that byte can be used to represent a data item or a character. Next, another one is word. A computer word, like a byte, is a group of fixed number of bits processed as a unit. It may varies because word word length also varies, right? But obviously it is again it's similar to a byte, but it's a fixed number of bits, right? That will be, all the fixed number of bits will be processed as one unit, and that unit always varies from one system to the another system, but always it's in fixed for each computer. The length of computer word is also called as word size or word length. The length of the computer word, we call it as a word size. What is the size of the word? It's nothing but the length of the computer word, and also we call it as word length. And sometimes it may be small as 8 bits or maybe as long as 96 bits. It varies. It may be a small or it may be a long. Small as 8 bits or long as 96 bits. So, computer will store the information in the form of computer words. Whatever the information a computer stores, that will be in the form of computer words. And now some of the units will be measured, or 1 KB. 1 KB is nothing but that is 1024 bytes. 1 kilobyte is nothing but 1024 bytes, or whenever we talk about megabyte, it's a similar to 1024 bytes. Megabyte previous term is kilobyte, 1 K, K means thousands, like 1024 KBs is equal to the 1 MB. Now we are talking about giga. Giga is thousands of mega, 1024 of megabyte, that will form the 1 gigabyte, and then terabyte, same, 1000s of gigabyte, that is nothing but 1024 GB is nothing but 1 terabyte, but 1 GB is nothing but 1024 of megabytes, and thousands of gigabyte forms the terabyte, thousands of terabytes will form the petabyte. So, these are some of the units and description. 1 KB is equal to 1024 bytes, 1 MB is 1024 KB, 1 GB is equal to 1024 MB, 1 TB is 1024 GB, 1 petabyte equal to 1024 TB. I think during the microprocessor session, we have we discussed how exactly it works, the microprocessor, right? But now, so with the same concept, we will try to understand how the CPU and memory works whenever you are executing some of the instructions, how exactly your processing unit and memory, because of course when we split the different components, CPU consists of all the things, memory, control, ALU, right, registers, everything all together we call it a CPU. But now we will try to understand how exactly the CPU and memory works when it is executing any one instructions. Example, here I have taken multiplying the two numbers. When you take two numbers, how exactly, by considering this example, how exactly the CPU and memory will work. So, I have given some of the steps, how exactly it solves the given example, and how exactly the CPU and memory works with respect to this. What is the first step? Control unit will recognize that program has been loaded into the memory. That means the purpose of this, or the task is multiplying two numbers. So, your control unit will come into the picture, because control unit is a main thing. It will coordinate for all your data, whether you want to receive the data or whether you want to send the data, or whether you want to receive the data from the input devices or you want to get the data from the memory. Everything this will decides. First what happens, this control unit will recognize, what it will recognize, there is a set of instructions, nothing but the program that has been loaded into the memory, right. So, once it is loaded into the memory, it will start executing. So, the first step in the program. Who will decide? The computer control unit. First, it will understand, it will recognize those set of instructions, whether that is loaded into the memory or not. If it is loaded into the memory, then immediately it begins to execute whatever is there in the first step. What is the first step in the program? Program will, you have a set of instruction, or you have an instruction to the user, or that is how you are written, enter the first number. That means you need to send one number, because the question is multiply two numbers, right. So, now first instruction for the user is you enter first number. Then user immediately what? It is, that means control unit pause, I am just expecting the data not from the storage unit, from the input device. So, immediately user what he will do? He will enter some number. Here I have taken 100 through the device. So, immediately the electronic signal, or that signal, whatever the input, the data which you have entered through the input device, that will be sent to the processor. That is nothing but the CPU. Immediately the next step, what happens? Again control unit come into the picture, because initially control unit has sent the signal to get the data from the input device, which is received and stored in the CPU. Now control unit will recognize that signal. What is that signal? Device has been, or your 100 will be, or has been entered by the device, input device. That signal will be recognized by the CU and routes that signal to an address, because see, it has received the data from the input device, that is 100. Immediately it sends, which control unit will recognize that signal, and immediately it will just it will send a signal, or it will receive that signal, and it establish the path, or we can say, and routes the signal to an address. It will send the signal to a particular address in the memory location, because I need to store that data for further calculation. Assume now whatever the data you have entered, that is 100, that will be stored in the memory address 7. Now immediately once it assigns the address for the particular first number, then immediately after completing the previous step, this above instruction, the next instruction, the next program, in the same program, but the next instruction is again for the user, you enter the second number, because already you have entered the first number and I have stored that number into the memory with the specific address. Now you enter the second number, then immediately the user will respond through the input device. You will enter 4, and again the same step, previous steps, immediately the electronic signal which is sent to the CPU, and immediately the control unit will recognize that signal, and again once again it will routes to the memory, because it has to store that value, right. Earlier it was assigned the address 7 to the 100, and now for this input it assigns the address 8. Now we have two inputs, like 100 and 4. 100 was stored in the memory address 7, and 4 is stored in the memory address 8. Now you just look at the next instruction. What is the next instruction? Will be multiply first and second number. Now multiply first and second number. To execute this instruction, who will do this job? Actually the ALU unit, there is arithmetic logic unit will do this job. Immediately the control unit will come into the picture. Control unit coordinate, or it sends a message, or it informs to the ALU. What is that? What is that information? I have two numbers that you need to multiply. So that information will pass it to the ALU. So that two numbers are coming, and the ALU is to multiply them. ALU will start multiplying those two numbers, and then the control unit next will sends to the ALU the copy of the contents, because it will not send the exactly the 100 and 4, it will send only the memory address which was, and 7, 100 was stored in the 7 and 4 is stored in the 8. So now the copy of the contents, whatever is there in this address 7 and address 8, it will send the, not actual copy, it will send the copy of that contents. Now, so ALU will receive that copy of that address, what is that 7 and 8 address, and 7 has the value 100 and 8 has the value, memory address 8 has the value 4. So now it will start, ALU will start performing the multiplication. Now 100 into 4 is equal to 400. So immediately what happens, ALU is finished his job. Now control unit again, it will receive that input or the performed or the result. The control unit it will send that copy, whatever the result you have, multiplied result 400, back to the memory unit. Again it sends back to the memory, and that output or that result 400 will be stored in the memory location. For that memory location that is stored in the address 9. Assume these are all the addresses. For one is input, that is 7 is for 100, 8 is for 4, and 9 is for the output of 100 into 4. Now next instruction is what? I am print the instruction is print the result. So that will be executed. Immediately to execute this instruction, again control unit sends the contents of the address 9. What is the address 9 consists of? Address 9 consists of the multiplication of 100 and 4 is nothing but 400. Control unit will send that contents of the address 9 to the output device, that is nothing but to the monitor. What is the result? That is 400. So the memory address 9 has the value 400 that you display. So finally it will execute the instruction end. Once it finds the end instruction, your program will complete, or the instructions, set of instruction. This is how it receives the end signal. This is how it stops the execution. This is how your memory and CPU, this is how the execution happens between CPU and memory. So quickly we will summarize just what happens because basically it's a control unit job. So whenever that similarly maybe the same steps you can apply it for any task. So here I have just taken only for multiplication of two numbers. First what happens, control unit will understand whether the program is loaded into the memory or not. Once the program is loaded into the memory, immediately first instruction it will start. So executing the first instruction, that is nothing but enter the first number, that will be sent to the user. So immediately the control unit send the signal to the input device, user will enter the first number, then it will send the signal to the memory unit, and it will route to the memory to store that value. The same procedure will happen for the second number also. Now we have both first and second, then it will give the instruction to the ALU. You just come and do that task like multiplication. ALU will just do that work, and then your again control unit will take the copy of that result 400 and it will store into the again memory unit, and then it will send the signal to the output. So through output device it will be displayed. This is how and after that maybe it will just once it found the end instruction, it will stop the execution. This is how our CPU and memory works whenever it tries to compute or perform something. Thank you.